I'll start introducing myself. My name is Birger Halfmeier. I work for APT in Melbourne. I'm a contractor. It's a travel company. I do business systems integration. Pretty boring stuff, but I use object-oriented languages, mostly C#. This talk applies to any object-oriented language or anyone who's worked with anything like Java, C#, or even C++. This is what it's not. So it's not about, so this is imagining you are a class or an object. So if you say I can do everything by myself, like, you know, I don't need you, just tell me what you want, I'll do everything. If I need another object, I can create my own. That's not outsourcing, that's doing everything in-house. Like, and you've probably all seen code that was kind of written from that sort of self-centered point of view, and then later you might have had trouble refactoring that code or even testing that code in the early phases if you were thinking of that. So this is a bit tongue-in-cheek, but yeah, that's not what this is about. What it is about is the opposite, outsourcing. So why would you outsource, like in the real world, and why would you want to outsource some of your responsibilities when you're implementing a class? Why would you not want to do everything by yourself? Well, you could say because it's cool and it's lean and agile, but really, and also you can talk about reusability and stuff like that. But really, it's because it's not everything can be your core responsibility. You can really only have one core responsibility, and other responsibilities are probably better placed in other classes. Okay, so again, what's the philosophy behind this? And a lot of companies do this in the real world, like Apple. They outsource the manufacturing of their iPad. They're coming up with a great design. You know, when you buy an Apple product, it says designed in California, and then it says made in China or something like that. And the idea is that, you know, they know exactly what they want. They specify this is what we want. I don't care how you do it. You may be working like that, but just make sure you give me the result that we've agreed on. So in some ways, it's designed by contract, and really just focusing on what you do best, and let other people do what they think they can do best, or what you know they can do best. And have some flexibility, maybe replacing one person with another person doing those things, whereas you can still focus on what you are best at. Right, so, okay. So here's a simple example. So let's say I want to...
Some of us got it.
Yeah, it takes a while, yeah. So let's say I want to make pancakes, right? So in some ways I do rely on other people in that supply chain to do their part as well. So, you know, I don't want to lay my own eggs, right? So all I want is eggs. I don't care about the implementation detail. I don't care that there are thousands of chickens in cages. I just want my eggs so I can make my pancakes, right? And I might know I need 4 eggs or whatever. I think that's fine. Okay, so now back to object-oriented programming, and this, I'm not sure, this might be a little bit more flexible in those dynamic scripting languages, but certainly in C++, Java, C#, those types of languages. Really, I think you should think of the constructor as an implementation detail rather than part of the interface, because it's not, right? So the constructor is not, like if you declare interfaces, the constructor is not declared as part of that interface. It doesn't get inherited. It's really just a special kind of static method that returns you a new instance of that specific class. And another piece of evidence is that you can't call a constructor on an instance of a class. You can only really call it as like a static method, like on the class itself. Which then leads us to the question, how would I pass around something equivalent to a function pointer if I can't actually have a function pointer to that constructor? And why would I want to? This is not about, you know, did the chicken come first or the egg, but sometimes you want a chicken and sometimes you want an egg. If you just want to make one pancake, okay, I need 4 eggs, give me 4 eggs, that's it. But if you need to make any random number of pancakes, you would like to be able to request eggs. Like you'd like to have the ability to get more eggs on demand, so the chicken might be more useful to you. Okay, so sometimes it's okay to share objects, especially like with eggs. Probably you can't really share eggs because generally you use an egg once and then that's it, right? You don't hand around the egg, you don't lend out eggs and then people give it back to you or something. So eggs I wouldn't consider stateless because you consume them and then you throw away the shell and that's it. But some other objects can be reused, especially if they're stateless, right? If the objects don't mutate as you use them, you can pass them around. They can even be shared like on multiple threads concurrently. If they're stateless, it's probably not an issue. So then you may not if it's that kind of egg, then you don't need a chicken, right? But if it is a stateful object, then you might want a chicken. That's just one way of thinking about it. And you could think of, okay, so if it's stateless, we can just have a singleton object, but that's not very flexible because, again, if it's just like a global static variable, then you can't really, mock it out too easily. If everyone just references that location directly. So it might still make sense to create one object and then pass it around using dependency injection or something like that. Okay, so other objects do get used up, like this engine did. And even in the store, like these two guys bought the same hat, and in this case there are others. But the point is sometimes things sell out. So if things do get used up, you really want to be able to produce new ones and allocate like whatever number of objects each consumer needs to each consumer. So then, if you want to enable that consumer to request its own heads or eggs or Rolls-Royce engines, then you might want to give them a reference to a factory rather than just giving them an engine which might explode. Okay, so maybe we need some sort of factory, and probably this concept isn't completely new to you. But there are a couple of different strategies, and I'll just go over those quickly. With factories, one pattern that is in the Gang of Four book. Who knows the Gang of Four book? That book there? Yeah, you don't have to have read it. But so the factory method is really a special case of the template method, where they've got this they've got this abstract application class. They've got an abstract create document, and then you could have any number of subclasses which then implement that create document, and each of those create document implementations might return an object of a different class, but all those classes would be, again, like in this case, this my application create document creates a my document object. That would be a subclass of this, and another subclass of application may have a create document method that returns an object of a different subtype of document that we can't see on this diagram. Right. That's still not very useful, I find, or not as flexible and modern as other things. Alright, so another possible code smell or anti-pattern is if you see new keywords, and again this is maybe different in some languages, but if you see new keywords scattered all over the place, that is probably not good practice, because essentially you are then making the creation of an object of another class your business, when really you shouldn't. Maybe you want to replace that Rolls-Royce engine with a GE engine or something like that. And you don't want to have to worry about how to decide which one to produce yourself. You'd rather outsource that. So again, you don't want to call the new keyword on the Rolls-Royce engine class. You want to maybe call a create engine method on some factory that you have been passed through your constructor or a set method. Right, so, and it also just gets messy, and you have tight coupling, and it's maybe you've seen issues like that in the past. Okay, so this is an example by Martin Fowler. I'm not saying that he's advocating this, but he's talking about this issue in one of his books. I think this is actually from his website. So what's wrong here? Can someone tell me in 20 seconds? Or what's the issue, given what we've been talking about? So, it looks like he's trying to do the right thing. He declares this interface movie finder, and then we can't see the code for it, but he's then created this subclass called colon delimited movie finder, or this class which implements that interface. But then we end up with tight coupling, because this movie lister class is constructor calls the colon delimited movie finder constructor directly. So it is actually tightly coupled to a specific implementation. It's not just coupled to the interface, even though it's declared here as a movie finder, it is actually through this constructor called tightly coupled to a specific implementation. And you can see how that might be difficult for unit testing as well when you might want to mock this movie finder. You could use constructor injection. We can't really see the code for this assembler class here, but the idea here is that the movie lister itself does not call any constructor. It gets an instance of movie finder passed in through its constructor, which also makes it kind of explicit and very easy to see that there's a dependency on the movie finder. That every movie lister needs a movie finder. It doesn't care which one. So the dependency is a bit looser because it's not tied to a specific implementation, just to the interface. And here, well, that doesn't really matter. That's just an example. Okay, one example that is probably a little bit complex. You could have this sort of global service locator, and that service locator would then, you call this service locator, you say, give me a movie finder. I think the worst bit here is that it's all static. Here we've got this movie finder method there, which returns you an instance of a movie finder. It returns this essentially singleton, so instance of movie finder, which can be configured through this static method there. So it's maybe a bit better, but you still, especially if you're thinking about unit testing, you have to do a lot of setup to make this work. Okay. Dynamic service locator is maybe a bit better. This is a bit more what the dependency injection frameworks do these days, like Spring and things like that, or Juice, where maybe not Juice. Yeah, the idea is the same. So where you've got a dynamic sort of collection, in this example, a hash map or dictionary or whatever you want to call it, where you get an object for each key, and this way you can dynamically configure it at runtime. So this data could, here it's hard-coded, but this could maybe come from an XML file or something like that, and then you could dynamically change that. Now, still, so dependency injection frameworks are good, but the service locator itself, you still have this sort of static, global, singleton thing that you have to access all the time. Still a bit ugly. So I've always liked the abstract factory pattern, even before using IOC containers. Has everyone seen this as a concept? So the idea, it looks a bit similar to the previous diagram, but so the idea is here we've got an abstract product, and we've got product A1, sorry, product A, what have we got? A1 and A2, they both inherit from this abstract class. Then we've got product B, and B1 and B2 both inherit from that. And this client depends on a product A and product B. Again, the dependency, 2 minutes? Okay, the dependency is only on the abstract classes, on the abstract base classes. So this client needs to be able to request a product A's or product B's on demand, but it doesn't care about the specific implementation. So what we can do is we can give it a reference to an abstract factory and then pass different concrete implementations of this abstract, it could be an abstract base class on interface, to that client. So if it is given a concrete factory 1, then calling create product A will actually return product A1, and calling create product B will return an instance of product B1, but with factory to it would return A1, A2 and B2. So that's a lot more flexible, because now we can have a dependency on the abstract factory alone, and we can actually pass around different instances of different implementations of this factory, and we can inject them through the constructor or a set method. I've got an example here with a pizza factory, and depending on what type of pizza you might like American style or Italian style. Anyway, it's a good book, you can look at the example, but yeah, so if you need high quality cheese, you might get it from a different factory than low quality cheese. And I think my time is up, but my recommendations would be use constructor injection where you can, because it's really explicit what a class depends on, and reference abstract types when you can. Use an IOC container to help you wire up your dependencies if it gets complex, but don't use them like a service locator. And if you need something like a factory, use an abstract factory and pass it around. All right, that's it from me.